In question 5, we are told that we have a student that balances a long-handled room XY horizontally across the top of the back of a chair. So the top of the chair O is at the distance of 1.05 meters from the end X of a handle. Now, let's take note that in order for the broom to balance, basically the CG must be on the pivot. And so we know that the CG is right now at this position. So when we tie a mass of 200 grams, a distance of 0.1 from NX, the broom needs to be moved 0.27 to the right to balance horizontally. So now if we redraw the broom, we're going to have a situation like this, where the distance to the pivot is now shorter by 0.27 and the CG has moved to the right by 0.27. And since our mass is hung at a distance of 0.1 meters, the force acting at this point over here is going to be 0.2 times 9.81. And from here, this becomes a very standard moments question, where the load over here provides a anti-clockwise moment and the weight over here provides a clockwise moment. So we have the moment provided by the load, which is going to be force, which is 0.2 times 9.81, multiplied by the distance back to the pivot, which is 1.05 minus 0.27 minus 0.1. And this is going to be equal to the weight of the broom multiplied by 0.27, which is the distance of the CG back to the pivot. So now, solving for the weight, we have 4.941. And of course, since weight is equal to mg, we need to divide this value by the gravitational field strength again, which gives us roughly around 0.504 kilograms. And so our closest answer to this is going to be A, which is 500 grams.